I'm going to do some examples of division in different number bases. We'll start with binary, and we can just use a nice little bus stop method. Okay, so I've got 1, 1, 1, 1, 1, 1, divided by 1, 1. Okay, so we see how many 1s fit into a single 1, and that's 0. Okay, so we carry along the 1. How many 1s fit into 1, 1? Well, that's a nice 1 exactly with no remainder. So we do it again. How many 1s go into 1? None. Remainder 1. How many 1s go into 1, 1? 1. Remainder 0. How many 1s go into 1? None. How many 1s go into, it'll be 1, 1, 1. So our answer is 10101 base 2. Next we're looking at base 5. So even though this is still quite a smaller number base, it gets quite tricky. Now when we're doing division, it's often quite handy to have like the times table of the thing you're dividing by. If you're dividing by 7, that's fine, you know that times table in your head. But if you're dividing by, like, say 27, you might want to jot down the 27 times table to help you. So we're going to jot down the 3, 1 times table because we're working in base 5, not base 10. So let's have 3, 1, and then if we add on another 3, 1, we get 2 here, but 3 add 3 is 6. We can't have that base 5. That would be a 5 plus an extra 1. And now we add on another 3 1s. We get 3 here. 3 add 1 is 4. So that one's alright. Now if we try and get the 4 times 3 1, we're going to add on another 1. And then we're doing 3 add 4. That gives us 7, which is a 5, an extra 5 plus 2. Okay. And then let's try one more. So we're going to add on another 1. Now that would give us 5. So that's 0 with a little extra 1 in the next column. 3 add 2, add 1 gives us 6. So that's 5 add 1. So we get 310. So that's times 1, times 2, times 3, times 4. And then that's kind of times 5. We shouldn't need that one. Okay, let's start dividing. So we've got 2, 3, 2, 4, 1. And we're dividing by 3, 1. So first we think, how many 3 1s go into 2? None. So we carry the 2 along. How many 3 1s go into 23? None. So we carry on the 2, 3. So now we're doing how many 3 1s go into 2, 3, 2. So we look down our times table grid and it's 4. And if we do 2, 3, 2, take away 2, 2, 4, what are we left with? Well, we need to borrow from the 2 there, so I'm going to use a different colour so it's a little bit less confusing. So I'm going to have to convert one of these 5s to lend it over here. So I'm now doing 5 plus 2, which is 7, take away 4 is 3. And then we've got 2 take away 2 is 0, 2 take away 2 is 0. We bring down the next number. Okay. How many 3 1s go into 3, 4? 1. And I can work out the remainder for that one, but I'm going to do the calculation. It's going to be 3. And then we bring down the 1. How many 3 1s go into 3, 1? 1. Okay. So our answer is 4, 1, 1, base 5. Okay. Now, if this is confusing, then instead you can convert to decimal and back out again. So we would have, we've got to the power 0, 1, 2, 3, 4. So we've got 2 times 5 to the 4 plus 3 times 5 cubed plus 2 times 5 squared plus 4 times 5, 1 plus 1 times 5 to the 0. And then we're going to be dividing by 3 times 5 plus 1. So this top number, let's work it out. 2 times 5 to the 4 plus 3 times 5 cubed plus 2 times 25 plus 4 times 5 plus 1. So we get 1696. And we're going to be dividing by 15 plus 1, so 16. So I just do that on my calculator. Oops. And that gives us, so 1696 divided by 16 is 106. So obviously that's decimal. We need to convert it back to base 5. So I'm going to start dividing by 5. So 106 divided by 5 is going to be 21 remainder 1. And then we take the quotient. 21 divided by 5 is going to be 4 remainder 1. And then we've got 4 divided by 5 is 0 remainder 4. And we're reading up the way. So we've got 4, 1, 1, base 5, which is what we had before.